Hi, this is Mr. Hodgen, and we're going to be doing the Unit 1 Solving Equations review for our test on Thursday. Let's get started. I'll remind you that you want to be able to do all these questions by yourself with no help. So if you're watching these right now and going to copy them down, make sure you go back and redo each question again until you can do it by yourself. Don't just write them down and say I'm finished with the review, because once you get that question on the test, you might not know how to do it. So very important you do these on your own. Okay, so let's read the directions for number 1. Circle all the equations that have the same solution. So basically we have to solve all of them and see if the answer is the same, and it does tell us there will be more than one. So let's solve all of them. So 2/3 of what number is 4? You might remember we need to multiply by the reciprocal. Since this is multiplication, if we multiply by the reciprocal, the left side will equal 1. Be very careful on the right side. If you need to, you can make that 4 over 1, right? So only do this when it's multiplication. So if this was 2/3 x plus x equals 4, you would subtract because it's not multiplying by the variable. Okay, so very important we know the difference between these two. One, you use the reciprocal. On this one, we would just end up subtracting 2/3 on both sides, not multiplying by the reciprocal at all. There we go, get that off there. Okay, so let's finish this up. So reciprocals equal 1, that's why we use them. They multiply. On the right hand side, we can cross cancel. 2 goes into 4 2 times. 2 times 3 is 6, all over 1, but we don't need to put over 1. So we got an answer of 6 so far. Let's go down here. 2 minus 8. 2x minus 8x is going to be negative 6x. Right? And we can divide both sides by negative 6 or multiply by the reciprocal, which is 1/6. Okay, that equals 1. And we get positive 6 here. So we got a positive 6 again. So we got 2 of them. Keep going. Now, you can see that this is minus 5 over 2. So you need to add 5 over 2. Don't multiply by 2 over 5. That's only if this was in front of the variable. So plus 5 over 2. So now we have x equal to, because that's 0. And then we have to add 3 over 2 plus 5 over 2, which is 8 over 2. And 8 divided by 2 equals 4. So those are not the same as the first two. Keep going. Do some distributive property on both sides. So we got 2x plus 8 and 5x minus 10. Right, we can subtract on both sides, about minus 5x on both sides. So that equals 0. And we can also subtract 8 on both sides. So I'm trying to get the variables to the left and the numbers to the right. Right? So one side you have to cancel out variables, the other side cancel out numbers. And then we're left with negative 3x equals negative 18. So once I divide both sides by negative 3, x equals, again, positive 6. Okay, and the last one here, e. Number in front of the parentheses is 3, so I'm going to distribute that. So I get 6x plus 3 is 45. Don't forget to bring down that 6 in the front. These are on the same side, so just combine them. 6 plus 3 is 9. Bring down everything else. 6x plus. There's 45. And then finish up by solving. Subtract 9 on both sides. We have 6 times what equals 36. And again, by dividing both sides, we get x equals 6. So it looks like we had quite a few that had an answer of 6. So you have to go all the way to the very last one and solve all of them. So I said circle all the equations. So I'm going to go through, say I would circle A, because that equaled 6, B, that equaled 6, and then D, that equaled 6, and E, those all equaled 6. Alright, good, that's number 1. Let's go ahead and do number 2. Very similar, but we're circling all the equations that have no solution. So, a little review on no solution. No solution happens when, such as we have an equation like this, and when you go to solve, the variables cancel out. Okay, that's the first condition. So the variables cancel out, and what you're left with, 4 and 5, you can see is not true. You're left with something that's false. 4 is not equal to 5. And that's how you get a no solution. If the numbers were the same or a true statement, then you would have an all real. So we're looking for variables canceling out completely, right, equaling 0 on both sides, and then the remaining numbers are going to end up creating a false statement, not be the same. Alright, so let's go ahead and give this a try. So we got 2x minus 11 equals 2x minus 10. And we have that situation right here. So if we subtract 2x on both sides, variables on both sides equal 0, and what we're left with is, well, negative 11 equals negative 10, which is not true. So that's going to be a no solution. Go ahead and solve this one. 1/3 of times what equals 0. And we still have a variable here, and there's nothing to cancel it out with. So you can see that the variables will remain no matter what, and this will have a solution. If we continue, we'd multiply both sides by 3 and get x equals 0. So this does have a solution of 0. Don't circle it. Here we go, letter C. So on this we do have the first condition met. We have the variables both sides equaling 0, but the second condition is that you have something false. But this is true. 5 does equal 5. This is going to be an all real solution. Okay, so that's the answer here, all real solution. So we don't want to circle that one. And lastly, oh, no, 2 more. Let's see here, we got 3x minus 2x minus x. That equals 0. So the variables are canceled out. So let's see if the left-hand side equals 5 or not. So we got 9 plus 11, which is 20. So 20 does not equal 5. This is a no solution. And there we go. Circle that one. Let's do one more. We got negative 6x plus 12 equals 12 minus 6x. So yeah, looks like these are going to cancel out when I add 6x to both sides, and the remaining numbers on either side are equal to each other. 12 equals 12. So this is an all reals again. So all real solutions. Okay, so we don't want to circle this one. Only the no solutions we're circling. So you can see the difference now between a no solution and an all reals, and an answer of 0. So only A and D were no solutions. Okay, let's go page 2. Okay, Mrs. Nelson wants to buy a cake and cupcakes for her daughter's birthday. Cake costs $48, and each cupcake is $3. Mrs. Nelson spent $123. Find all the possible ways to write an equation and solve for how many cupcakes Mrs. Nelson purchased. And there can be more than one yes. Alright, so let's just write this out, that we know total we spent $123. So let's say this is $0, and then this whole thing will represent $123 from here all the way to here. We know that 48 of that, right, consists of just buying the cakes. That's $48. And we know that there are a number of cupcakes that cost $3 each, so I'm going to say the rest of this, the rest to get to $123 is going to be $3 times however many cupcakes we purchased. And so I know that the 48 plus the 3 times my cupcakes should add up to 123. So 48 plus $3 for each cupcake is going to add up to $123. And we can look for different variations of this on the list. Note that the cupcakes should be associated with the $3, so something like this where it says 48C, that'd be like $48 per cupcake. So you know that's not going to be it. Okay. And we can see maybe like on the bottom one it says $3 for each cupcake equals $123, but they left out the $48 for the cake. So we know that can't be it. The rest of these all have the 48, the 3, and the 123, and we just have to match them up carefully. So I think what we have matches exactly here, right? But if we start solving this, let's say if I want to subtract 48 on both sides, I'm going to start to solve the problem, right? I end up with 3C equals, well, whatever 123 minus 48 is. And that's what it says right here. It's just written horizontally. Instead of having the 48 below, it's written to the side. So that's the same thing, because you'll get the same answer. The one we haven't done yet here says it's minus 48, but even though we subtracted 48 both sides here, it's on the wrong side. It's okay because we have it on the right-hand side here, but minus 48 means like, well, $3 for every cupcake minus the cost of the cake. But really, we have to add in the cost of the cake. So, yeah, I think we end up with these two being yes. Because another way of looking at this is if you solve all of these, you should get the same answer. Okay, let's solve and check, as it says. We got to solve, then check each of these. So basically, -5 times what is positive 45? Solve it, divide both sides by -5, and we get -9. Right? And then just verify that. We can do it mentally, but here you have to show it. So they're basically asking, well, does 45 equal -5 times -9? And if you get the same number on both sides, then that means yes, you have checked it. If you get a different number, then no. Be careful on this. Don't just write something down and then at the end put a check. The work has to actually equal it. If it does not equal, don't make it up and just change it. You have to redo it because your answer is wrong. Let's do number 5. I'm going to rewrite this first. Instead of x over 3, I'm going to write this as 1/3 x. Okay, so remember, this is a 1 in front, and I'm just bringing that x to the side. So let's subtract 2 on both sides. We have 4 equal to 1/3 of what number? So a third of what number is 4? And then multiply by our reciprocal, which is 3, or 3 over 1. So we get 12 is equal to x, and then do a check. So we got, does 6 equal 2 plus 12 divided by 3? So just do a little order of operations. 12 divided by 3 is 4, and sure enough, we do get 6 on both sides. Let's keep this going. Subtract 7 on both sides. We get 6x equals 42. Divide both sides by 6. So x equals 7. Do a check. Does 7 plus 6 times 7, does that equal 49? And sure enough, it does. Still have to write out all the work and prove it. Your last step on a check should be same number on both sides. And let's finish up this. Two ways of doing this. I can either multiply both sides both by 1/4, or I can cancel out and multiply by 4 and cancel out the fraction. Either way will work. I'm just going to multiply by 1/4. So I'm going to get 8 over 4x plus 12 over 4x equals -3. Now 8 divided by 4 is just 2. So I have 2x, and 12 divided by 4 is just 3. And I have 3. Alright, now let's solve it. Subtract 3 on both sides. 2 times what is equal to -6? And when you divide both sides by 2, you'll get x equals -3. Let's do a check on it. The original problem, we got 1/4 times 8 times -3 plus 12. Does that equal -3? So I have to simplify the whole left side and make sure it equals -3. If it doesn't equal -3, I've done something wrong. So I'm just going to start on the inside. So I have 1/4 of -24 plus 12. Do the parentheses. -24 plus 12 is -12. And then 1/4 of -12 is -3. So that checks out. Alright, let's go to page 3. Let's again solve each equation and do a check. So we're going to check these as well. So let's start off by distributing on both of them. Careful that you see the number here is -6. So I'm going to multiply by -6 on both of these. So I have 4 times x is 4x. 4 times 1 is 4. Right? -6 times x is -6x. -6 times -3 is +18. That's the most common mistake on these problems. Make sure you include the negative. And bring down the -40. Alright, we have these two on the same side. I'm going to combine them. And I have +4 and +18 on the same side. So 4x minus 6x is -2x. 4 plus 18 is 22. That equals -40. And now we can finish. Subtract 22 on both sides. -2 times what is equal to -62. And divide both sides by -2. I got x equals 31 positive. Negative divided by a negative is a positive. Okay. And now go ahead and do a check. So we have 4 times 31 plus 1 minus 6 times 31 minus 3. Does that equal -40? Alright, so let's simplify this. That's going to be 4 times 32 minus 6 times 28. Does that equal -40? 4 times 32, let's do 4 times 32, I get 128. Okay. And then 28 times 6 is going to be 168. So that's looking good. It's going to be negative. And then sure enough, 128 minus 168, 28 minus 168 does equal -40. So that checks out. Let's move on to number 9. This is a proportion. Two fractions or ratios equal to each other. Let's go ahead and cross multiply. So 8 times x should be equal to 5 times 3. Alright, so 8x equals 15. Go ahead and divide. Divide by 8. And let's see, can that be reduced? No. So x just equals 15 over 8. Now if we do a check, we have to do 15 over 8 divided by 5 should be equal to 3 over 8. So let's just simplify the left-hand side. I'm going to rewrite this as and division sign. So these are identical. 15 over 8 divided by 5, 15 over 8 divided by 5. That's the same as 15 over 8 times its reciprocal, 1/5. And then you can see the cross-canceling leaves us with 3 over 8. So I do have 3/8. Okay, good. Keep this going. Number 10. Again, make sure you see that there's a -3 on the inside here. On the left side, I see a couple of like terms I want to combine, so I'm going to do both of these on the same step. 9x plus 3x is going to be 12x. I'm just going to bring down that -5. And then on the right-hand side, let's do some distributive. -3 times -2 is -6. And -3 times -5 is positive 15x. Alright, now we can solve the rest. I am going to, how about subtract 12x from both sides. And then let's add 6 to both sides. Remember, there's a couple ways of doing this. As long as one side cancels out variables and the other side cancels out numbers, you're okay. -5 plus 6 is 1. And 15 minus 12 is 3. So I got 3x. 3 times what is 1? And then go ahead and divide. So we have 1/3 equals x. There we go. Let's see here. We need to do a check. If I got some room over here. Let's see, I have 9 times 1/3 minus 5 plus 3 times 1/3. Okay. And that should be equal to, well, let's go ahead and simplify that. I get 3 minus 5 plus 1. So that's going to be -1 if I simplify it. So I know the left-hand side equals -1. Now let's plug 1/3 into the right-hand side. So I have -3 times 2 minus 5 times 1/3. Alright, so let's do some distributive property. I'm going to get -6. And when I multiply here, it's going to cancel out the 1/3. 3 times 1/3 is 1. Negative times negative is positive. So positive 5. Basically, the 3 and the 1/3 canceled out. So I get -1 on the right-hand side as well. Both sides equal -1. Alright, one more for our solving and checking. Remember, if you have a binomial or two terms on the top or bottom, go ahead and put parentheses around them. So I'm going to multiply these two together and get 3 times quantity x plus 3, and then 5 times 6, which is 30. Go ahead and divide both sides by 3. I could distribute, but I'm going to divide both sides by 3 since 3 goes into 30 evenly. So I have x plus 3, because these cancel and equal 1, and 30 divided by 3 is 10. So what plus 3 is 10? That would be 7. Subtract 3 on both sides. X equals 7. Okay, do a check. So does 7 plus 3 over 6, does that equal 5/3? Sure enough, we have 10 over 6, which reduces to 5/3 when you divide top and bottom by 2. That checks out. Okay, let's do some of the word problems. Make this fit on here. Okay, if Rebecca earns $11 per hour, she earned a $40 bonus, one-time bonus for being Employee of the Month. Her paycheck was $260. Okay, so let's look at this. Kind of like to draw a picture to see what I'm doing. I know she made $260 total, so $260 from here to here consists of making $11 per hour. I'm going to call that 11H for some amount, but then also a $40 bonus. So a little bit of that 260 consists of just a $40 bonus. So what I'm trying to find is H, how many hours she worked. I'm going to call that hours worked. Okay. My equation, remember these two will add up to the bottom, the whole thing. So this piece is 11H, $11 an hour, plus the $40 bonus should add up to the $260 check. And then we can solve this. So we have 220, and that means if you got $220 for working $11 an hour, see 11 into 22 is 2, so 11 into 220 would be just 20. So she worked 20 hours at $11 an hour, and that made $220, and then plus the $40 made $260. Okay. So write a sentence, and you can say Rebecca worked 20 hours. There we go. That suffices. Period. Do a few more word problems. Get this to fit. Okay. Michael's making a down payment to purchase a computer. He could pay $275 down and $50 a month, or $200 down and then $75 a month. So two options. We have the one-time $275 down, and then we got $50 per month. We also have a little less down, $200 down, but then you're paying more per month, $75. Right? And let's see here. And we're trying to find out when will they be the same. Okay, so basically when are they equal to each other. So we know that M is the number of months, because it's asking how many months would it take for them to be the same. So that's the number of months. I mean, you can basically copy it down, number of months for paid amount to be the same. Paid amount to be the same. Okay. I just took this whole sentence right here and wrote it down for my variable. All right, write an equation. So we want to know when they're going to be the same. Same means equals. So when are these two equal to each other? So when is $275 plus my $50 a month equal to $200 plus $75 a month? So I have $275 plus $50 a month. When is that equal to the $200 down? $75 a month. And let's go ahead and solve this. I'm going to subtract 200 on both sides. I'm also going to subtract 50 M on both sides. So again, one side cancel out variables, the other side cancel out numbers. It does not matter which side has which type of number. So we have 75 is going to be equal to 25 M. And then when we divide both sides by 25, we get 3 equals M, which means it only takes 3 months for them to be the same. So if you're making more than 3 payments, okay, you probably want to go with the first one, right? If you're making less than 3 payments, you can go with the second one because it's less money down. So take 3 months for amount paid to be the same. Alright, and that concludes the review. Make sure you can do this entire review by yourself with no help, okay, and get it 100%. You can see by the counter here that it's on the video, this is about 31 minutes, so you have about 50 minutes to take the whole test. So keep practicing until you get it down to at least about 50 or 45 minutes to complete everything without stopping and getting 100%. Please print out as many of these as you need to practice over and over and over to be able to do that. Okay, good luck.